School for Poetic Computation. I have a new Coding Rainbow theme song. I'm not ready to play it for you yet. However, in the background right now are the instrumentals for this theme song. And I see that things are working. Please let me know in the chat if you can hear me and see me okay. Yeah, okay, I see that I have green bars for audio. So anyway, welcome. My name is Dan. I'm here live at the School for Poetic Computation in New York City in the West Village. The school is actually having their final showcase this week on Saturday and Sunday. If you happen to be in the New York City area and want to come see the projects of 12 students here and what they're making and working on, please do. So first of all, okay, if you're watching this as an archive video on YouTube, check this video's description. There'll be links to time codes where various tutorials will happen. Also, at some point, this will be about a 2-hour session. I hope that at least 3 or 4 standalone 10 to 20 minute video tutorials will come out of it. So you can look for those separate videos if you don't want to watch this long, probably messy and scattered live stream thing. But I'm a little bit out of sorts this morning, and I know that something is going on here. When, one of the things that I do, so I teach these classes at a school called New York University, for better or worse. And I have this habit of, if I have to teach, say, on a Tuesday or a Thursday or a Friday, the night before I'm always up late looking at things and trying to prepare some example or getting panicked and anxiety-ridden. And strangely, that hasn't happened to me doing these live sessions. I just kind of show up, turn it on, but it started last night. So somebody had suggested, Verto in the chat asked, did you do the Khan Academy recording? I did not. Khan Academy was having some sort of video contest, and I was like, oh, maybe I'll make a video for it, and I don't think I ever did. People are here hoping for dancing. That's interesting. It'll happen, I'm sure. So one of the things that I have associated with my channel here is a GitHub repository called Rainbow Topics. And a topic that I will tackle, that I am planning to tackle at some point, though not today, for the reasons that I'm telling you this ridiculous story that probably nobody cares about. So there is, I put this in, one of the topics is something called Navier-Stokes, which is a particular kind of algorithm for fluid simulation. And actually there's another suggestion here, these are kind of related, called fluid dynamics. And there's some other references here. People are interested in this. And so I thought, oh, I've worked on programming things with processing for like 15 some years. And I've done fluid simulation stuff before. I've used a library called MSA Fluid. I found this other library. I think I might have, I've made little quick experiments. And I thought, okay, I'm gonna prepare this for tomorrow's session. And so I found myself at night, fluid dynamics for games, sitting in this, is this the paper I'm looking for? Yes. No, wait, hold on. I just want to make sure, because this is not the URL that I'm used to seeing. Yeah, this is it. This is the URL that I'm used to seeing. Fluid, this one. This, I believe, yeah. So this is sort of a well-known paper, which describes a particular algorithm for creating real-time fluid dynamics. I would say you could, let's see if I am back now. That was very, very sad, but okay, hopefully things are working again. Okay, so I was in the middle of telling a story, a really not very interesting story, but I was telling the story nonetheless. You could always turn this off and do something else, or maybe this is just in the background. But anyway, okay, so I was reading through this paper, and I was looking here, and I was like, okay, this looks good. A grid, that makes sense. We got a grid with some edge cases of 0 and n+1. Okay, this is good. Okay, we're gonna make some arrays. This idea of density, and this is very similar to, if you look through some of my previous tutorials, I did a tutorial on reaction diffusion, where you have this grid. Each cell in the grid has some amount of chemicals in it, and you add some forces, and that stuff diffuses, and it combines, and then you visualize that with colors, and this is good, and now we have some formulas. We have neighboring, so the fluid stuff goes from one neighbor to the other, and we're going through here, okay, looks kind of messy, but we can do this, and I can port this code, and et cetera, et cetera. And then I started realizing, it's like 11:30 at night, I'm getting a headache, and I came across this particular part of the paper which says, the following code implements this idea, and we use a simple, can you hear me? Yes, a simple linear backtrace. And I was like, looking at these formulas here and thinking, you know what, maybe I'm not going to do Navier-Stokes fluid simulation on tomorrow's live stream. So, I have this quandary, which is to kind of, in picking topics, there's always this question, I think, that comes up in doing creative projects. For example, that was a loud noise in the other room. I have more than one sound effect. Not that you guys really want me to play sound effects. Okay, so if I was doing fluid simulation, I might go ahead and look for something like this particular. Ooh, look at all these beautiful. Hold on. Can I start over? I can't just delete this and start over again. I feel like the point of what I'm saying is I didn't get very much sleep. Very tired. My head's in a strange place. I was really thinking about this fluid stuff. I was having nightmares where the fluid was taking over. I was being drowned in the Navier-Stokes fluid simulation. Ooh, look at this, P5. So anyway, there's this balance that you have to strike, which is I want to create a project. I could implement an algorithm from scratch. What's the utility in doing that? What's the value in kind of learning how to do that? What's the value in using a library or another implementation? And I'm kind of walking along this fine line in this thing called coding rainbow. And I think right now I've discovered that the fluid simulation algorithm is a particularly advanced, large case scenario that would merit multiple videos going through all of these different steps, possibly also looking at using a library. So anyway, I want you guys to, I want you guys to keep me in check here. What I've noticed is that, in particular, the live stream audience has generally a pretty sophisticated background, and I would like to make sure that I'm doing a good balance of tutorials that are kind of quick and easy and accessible to create interesting experiments and projects, beginner friendly, little experience necessary friendly, as well as spots where people can go further in depth, building on previous tutorials and previous skills. So anyway, so keep in touch, especially if you are a beginner, if programming is new to you, if it's something that you've only been doing in the last year or in the last week or in the last day. Have you been able to find the tutorials that I have on YouTube that have no experience necessary, and have those tutorials been enough for you to follow those and then go on to some of the other ones? This is something that I would like to hear some feedback on. Mostly the feedback that I'm getting is requesting hey, could you build a ray tracing engine from scratch? And so, not that I think that could be interesting. It's interesting as an exercise. We'll learn something about code, and we might discover something new. I want to do all that stuff too, but I want to keep that balance. Okay, so that was my little spiel for this morning. I'm trying to figure out where all my music is. Oh, there's some of my music. So I'm getting ready. Today is going to be a day, though, however, of looking at some interesting algorithms, like Poisson Disc. What's another one that I was thinking about? Diffusion-Limited Aggregation. We're going to do all these things. We're going to make some cool stuff. I'm going to work in JavaScript, maybe in processing, and we will see. Oh, I also wanted to look at some circle disk point picking. All these things that don't maybe sound that interesting, but I assure you they are. Okay, so let me get through a few things. So just in case some people are new, I'm going to just run through something that I always run through, which is that you can go to codingrainbow.com for all of your Coding Rainbow needs. I encourage you to subscribe on YouTube. You're welcome to join this crowdfunding website, Patreon, if you feel so inclined. By no means are you required to, of course. I will always be here and enjoying your company virtually. And then you can also put your email in here if you're interested in signing up for email announcements for when I'm going to do a live stream. I should mention that this is my last live stream for this week. I plan to have at least one live stream next week, and then I'll be on hiatus for like the last 2 weeks of August. However, I have a not huge, but I have a backlog of maybe like 10 to 12 video tutorials that are kind of been edited from the live streams and haven't been published yet. So I hope that even while I'm away, I'm going to be releasing a video per day. And obviously, if you're subscribed, you will get a notice for that. Okay, so that's the spiel there. And let's see. So let's see if we can, I don't know, let's see if I can just get started here. Let me put on the, nope. Sorry, having a little frog in my throat. No. Okay, so I'm gonna look at some of these. I feel like there's a theme to today, and the theme for today is random circles appearing. Right? So let me get set up here for a second. It would be good if I ever did this stuff in advance. So let's let me go to oh, I remember something I was going to talk about. By the way, this music is composed by Adam Blau. At Adam Blau on Twitter, I think. Okay, wait, I should do some programming. Okay, Phyllotaxis, I think that's a good, let's, random circles 1. All right, let's see if Addem worked. I was having a problem with Addem. Let's see if I'm still having this problem. Yeah, I'm still having this problem. I forgot to check into this problem and fix it. Let's show the stack trace. Let's see if we can fix this for a second. Why is the beautify package seem to be having some sort of problem? Anybody know what this error could be? Hides beautify is having some sort of problem. Maybe if I package Addem beautify debug package manager, where do I do that? Addem preferences, maybe check for update. Let's check for update. Latest version. Preferences. Whoops. That's with some of the lyrics. Wait, hold on. I was just trying to put on some music for you guys. Here we go. Packages. Disable. Update. Let's try that. The WG Bros asks in chat, are you going to make another episode of the Agario remake? I am going to. I don't believe that I'm necessarily going to tackle that today, though, however. But I will definitely be continuing that at some point. Is it updating? How do I know if it's working? It's hot in here, so I think I need my sweatband. Which I think makes my head separate from my body, because it has a green stripe on it. All right, let's see. How are we doing here? Did it update? Okay, it update. Let's restart. Hey, okay, fixed. Okay, so now I made at some point. Let's look at an interesting problem. I think this is going to be an interesting problem. So there's a lot of steps to this thing that I want to show you. I'm trying to think of where I want to start. Let's start with this. Let's just say that I have a. Hold on. Why do I have Slack open? Quit. QuickTime open. Quit. Okay. Let's say that I'm going to now go to. I need to run a little server. Oh, let's add this. Addendum live. Okay, so let's try to add a new package. So something that that I was told that I should consider using is, let's see, how do I find a new package? Install live server. Addendum live server. Launch an HTTP server with live reload capability. Let's see how this works. And then I was going to talk about CodePen. I knew I had something else I wanted to talk about. We're going to do some CodePen too. Let me pull up my information on CodePen. Okay. Okay, how's that? That install? So now, everyone, let's see. How do I? Does anyone know auto live server? Start. Look at this. Look at this. What port should I use? I cannot even imagine what port. Oh, I know. Wait, is this it?
9, 2, 7, 6, 1, 9, 4, 8, 9, 2.
That's a bad joke. Okay, let me just, okay, let's try port 3000. Look at that. How lovely. Now, we don't need to worry about this silly. So look at this. What if I just were to add now, let's try something. So one of the things I was going to show you is, what if I just say, I'm going to say stroke weight 4, point, random width, random height, stroke 255, 1,000 points. So, whoops. Look at that. I don't even have to do, let's make it 5,000 points. Look at that. It reloads automatically. So this is, first of all, so this is exciting. I encourage you to use that. I lost track of my chat here. Okay. Okay, so here's the thing. I think an interesting, there's, how you distribute random points into a window might seem like, in many ways, not that interesting of a topic. And in fact, here in about 10 seconds, I created this sketch that just made a whole bunch of random points in the window. And we could discuss, there's some issues or not issues with this, but we could say, like, what if we wanted to have a scenario where we distribute these points randomly, but none of them are overlapping? And in fact, I did previously do a video on this topic, Shiftman, YouTube, random circles. Let's try to find that, right? Yeah, random circles with no overlap. You can kind of see what's going on here in this thumbnail there. And we don't need to watch that video. So, and what I did in that video was employ a strategy that is often referred to as dart throwing, essentially, which you could imagine here. What if I'm throwing darts at this canvas? And every time I hit the canvas with a dart, I hit the canvas with a dart, I draw a circle there. And then I throw another dart. It hits over here, and I draw a circle there. And I throw another dart, it hits over there, and I draw another circle there. What if I throw a dart and it lands on top of one of my previous circles? Well, then I go and I pluck that dart out, and I throw again. So that's, if you go back and watch that previous video, I looked at that strategy. Now you can imagine why that's not that efficient of a strategy, because if my canvas is full of all these dots and I throw a dart, keep throwing darts, I'm gonna have to keep taking it out a lot before I find, by accident, throw it somewhere where there's a random point. So I want to kind of take this as a broader theme for today. And this camera's about to shut off, I bet. I want to look at a bunch of different algorithms related to this theme. One that I found through the JavaScript programming environment called D3. And this is something called Poisson Disc Sampling. And you can see how these particular dots are distributed randomly. None of them are overlapping. And they exhibit this Poisson. Poisson, les poissons, les poissons. Named for the French mathematician Poisson, not from The Little Mermaid. I don't know. It's actually also a French word meaning fish, clearly. But you can see how not only are they not overlapping, but they have this kind of even distribution, right? A Poisson distribution of random numbers is kind of related to if something happens about 4 times randomly per day, what's that kind of distribution going to look like over time of those 4 events each day? I mean, they generally aren't going to cluster all together, that sort of thing. So you can read more about Poisson distribution, Wikipedia, etc. But so there are various strategies for making this kind of distribution, one of which that I did mostly in my previous video was this sort of dart throwing thing. So I was looking at this, and there's this sort of like amazing simplicity and beauty to this, even though all it's doing is filling it with random spots. But you can imagine different kind of applications for this. Some other type of, I did a video about a space colonization algorithm which draws a tree pattern as it's pulled to random points. And I just put all those points randomly in the window. What if I used this kind of distribution? What sort of tree would I get out of that? If I was creating an ecosystem simulation where I wanted to create a sea of food, or I wanted to have blades of grass over a meadow, what if I gave all the initial points of distribution like this? So, and someone in the chat is writing, the Poisson distribution is used for molecular modeling. That's great to know, super interesting. So this is kind of a theme. I want to maybe start with this, and we're going to look at, I actually have not programmed this, but we're going to look at this particular paper by Robert Britson, which describes the algorithm. I don't know if the source code for this is available on the D3 website. It probably is. We could look at that as well. And then, other things related to this that I want to look at is circle disk pointing, disk point picking, to kind of look at the distribution of picking points inside of a circle, whether they cluster randomly towards the center or evenly spaced out. That's something I want to look at, as well as one of my favorite algorithms that I think that I've implemented before. I didn't include it in the Nature of Code book, but is called Diffusion-Limited Aggregation. And you can see that this is a kind of an algorithm that can model crystal-like growth patterns that happen in nature. And we can kind of peek through this Wikipedia page, and you can see that you can get different patterns based on whether you start growing from the bottom or out of the center. And I'll probably use, I'm Paul Bork. Paul Bork is a person. He has a website that I use that I've found lots of really nice explanations of various algorithms on. Let me find this. Diffusion-Limited Aggregation. So I think we could read through this together. We can have like a soothing, quiet. You guys could maybe all of you are watching somewhere and you have like a couch or a bed nearby and a pillow, and you could lie down, put on some quiet music, or better yet, I could put on some quiet music for you. And then you could lie down and I could just read to you from this paper, and I could say things like, Figure 3 shows a box attractor. New points enter in the interior. The center of the image, say. The source code supplied here. The soothing voice, and that could be how you could go to sleep at night. Okay, I lost track of my head there. So I don't know, I'm not sure whether, so that's kind of my plan, broader theme for today. I'm going to be doing these as coding challenges, meaning I will essentially, this is empty, it's a prop. I will be programming them from scratch while reading through either the paper or the website that explains the algorithm. I feel like that's a really useful process for people to see. I enjoy doing it as this kind of like a strange performance art kind of academic math paper programming code in P5.js thing. And that's sort of my plan for today. So there are some questions going on in the chat, which may be... yes, so by the way, the Poisson distribution, which we'll look at, and I believe on this page, the Jason Davies page, that, by the way, there's also some further reading down here of other links you could look at. You can look at random points on a sphere. So these kinds of things can also be used to, and this is interesting for sort of mapping applications and stuff like that. So this is what I want to look at today. Okay. Okay, so let's see. I think there must be a lot of new people in the chat today. I'm seeing lots of new names. So ask your questions. I kind of take a peek at the chat as I can, but I'm not glued to it. Unfortunately, it's sort of a little bit hard to do that. Okay, so let's start with, let me close all this stuff. And let's see where am I here? Distribution. Let's find the GitHub issue. No, what was it called? Random sampling of points. Oh, okay. Oh, the other thing I was thinking, it's sort of, I don't know. The other thing that I was thinking was, whoops. So one of the things that I wanted to also tackle is the traveling salesperson algorithm. And the I don't know if algorithm is the right word, actually, traveling salesperson problem. So the traveling salesperson problem is a problem where you look at a space full of points and you try to say, what is the path? I'm a traveling salesperson. I'm here to sell my rainbow, my rainbow sweatbands. Here I am. I'm a traveling salesperson with rainbow sweatbands, and I want to visit all of these cities, and I want to sell these things in all of these cities. What's the shortest path so that I can go from one city to another and hit all of them and walk the fewest amount of steps? And this is a surprisingly difficult problem to solve once you start having a lot of points, because there's just so many possible paths through all of these points. And so we could use a kind of check every possibility and find the shortest one approach, or a genetic algorithm to solve this problem. So I think it's sort of interesting to think about some of these algorithms for generating like a diffusion-limited aggregation visualization, and then apply the traveling salesperson problem to it. So you connect all of them with a line or that type of thing. Okay, can you tell us what you use for browser live reload? I'm using a package for Addendum called Addendum Live Server. And I guess if you watch this back in the archive, I went through the steps of installing it. Okay, so I wanted to talk a little bit about CodePen. I think since I've been kind of going on and on and on and on without actually getting to anything yet, I think I will save that perhaps for a little bit later. But I want to mention that I did a tutorial using CodePen the other day. I used CodePen, has this thing called Professor Mode, where you can actually be on the same web page as me and see me typing the code in real time. The problem is you're about 15 or 20 seconds behind on the YouTube stream, but the actual CodePen thing is in real time. Anyway, I made all sorts of mistakes and had some questions about CodePen, and I got an email from a CodePen engineer, and I got answers to a lot of those questions, and I want to go over some of those at some point. Okay, so let's start with the Poisson Disc Sampling. Let's start with that. Okay, so let's look at this particular paper. Is everybody in their quiet couch? Okay, so what I'm going to look for actually, so I encourage you to read the whole paper. You sort of get the idea though that what we're trying to do is, and this is by the way, visualizing the distribution of probably distances between all the points. Somebody correct me if that's wrong. But anyway, this is the goal here, right? To create a random distribution of points in a plane that exhibit that aren't overlapping, and they all have a minimum distance. None of them are closer than a certain threshold. and that will give them this kind of like even but random distribution. So we could use the dart throwing approach. I did that in a previous video, so I'm not going to do that here. Instead, what I'm going to do is read starting from the algorithm here. And the point of this algorithm is not to make a more beautiful version of the distribution, but to have an algorithm that actually runs rather quickly, which in this case really can make quite a difference if you're doing in a lot of cases, in a lot of scenarios, for me, I don't really worry about optimization. Like, I'll just make my interesting weird project and try to make it work, and I can optimize later. I think that's generally a good strategy. But this might be a case where you already know, like, I have a high resolution image. I want to fill it with points, and I need to do that like every frame. I can't like have it take a super long amount of time. Plus, I think we're going to discover some interesting programming techniques while doing this. I read this on the subway this morning, so hopefully it's going to work. So I think we're going to discover some interesting techniques, and also the point of this channel, Coding Rainbow, is to look at some of these classic algorithms, implement them verbatim, and then for you, the audience, to do your own creative riff off of it. Okay, here we go. So I want to make this a separate standalone tutorial. So I am going to cycle these cameras. I'm going to get myself ready. Okay. Let's say we're going to have, okay. Go here, 1,000. Okay, I'm going to do this in JavaScript. I got the browser going. We'll close this right now. Okay, and here. Okay. I can't see. Hold on, I got to fix something. Here we go. So this wasn't so great. This is probably about 45 minutes before I actually started doing anything. But thank you guys for bearing with me and being here with me this morning. Okay, this is a very serious topic, so I won't be wearing my sweatbands. I'll wear one. No, it's too weird. Okay. Okay, here we go. Welcome to a video tutorial where I'm going to read this paper in this video out loud to you. So if you ever thought, oh, you know what I want to do? I want to watch a video on YouTube where somebody reads out loud to me an academic paper with some math stuff in it. you come to the right place. It is called Fast Poisson Disc Sampling in Arbitrary Dimensions. Just to kind of cover what that is, the idea here is that I want to fill a space with points. These could be, I want to use this to create a, I can't think of any good examples, like an ecosystem simulation where creatures are wandering around. I want to fill a space with food, or I want to use these as seed points for some type of other generative growth algorithm, or I just want to have a nice pretty dots pattern that then I color according to some image, and I want those points to be evenly spaced around and not overlapping. So let's look at how we can implement this algorithm. And I'm not going to read the whole paper. I'm just going to start from down here. And the idea is the algorithm takes, and by the way, just so look in this video in the URL for this paper, and it's by Robert Britson from the University of British Columbia. And this is, I think, from, I assume that this 07 means it's from 2007. So the algorithm takes as input the extent of the sample domain, the minimum distance r between samples. Okay, so what does that mean? A sample, by the way, is each one of these dots. That's a sample. So I first will need a minimum distance. So I'm going to go to my code. Oh, by the way, what's my code doing right now? So I'm starting with this code written in JavaScript using the P5JS library. And it just draws what has a loop to go from 0 to 1,000 to draw 1,000 random points in a window. And we can see that's happening here. And you can see that these points don't have that kind of distribution. They're overlapping. They're not kind of evenly spaced. This is a perfectly fine distribution. I have nothing against this particular pattern whatsoever. But it's interesting to look at other patterns of what types of beautiful things could emerge out of that. OK, so Here we go. Okay, so now back to the paper. Where was I? Okay, so let's go. Okay, so R. So I need to add R. So I'm going to add a variable, R. And let's say right now we're going to start with, I want these points to be 10 pixels apart. That's kind of a reasonable value to start. And then a constant K. What is K? As the limit of samples to choose before rejection in the algorithm. Typically, K equals 30. Okay, so well, that means to me I can create a variable K equal to 30. But what does that mean, limit of samples to choose before rejection? So probably in the algorithm, I read this before. I haven't implemented the code yet, but I did read this before, so I know. But what it means is there's going to be some point where I'm going to try to do something a certain amount of times, and if it doesn't work, at some point I'm going to quit. And this is telling the algorithm to quit after 30 times. And that's obviously, both of these are numbers we could play with to see if we get different effects. So now what I want to do is initialize an n-dimensional background grid. Oh boy, what is an n-dimensional background grid? That sounds complicated. Sorry, I just needed to get to my keyboard here. So what I want is to have a two-dimensional background grid. Meaning I want to think of some sort of grid. And what I'm going to do is I'm going to store everything in that grid in an array. So I'm going to make actually just one, I think I'm going to make a one-dimensional array. And that one-dimensional array will number every single element in that grid. And this is what I do. I've done this in countless different examples and things online, where online on YouTube, on the internet, this is where I have this one-dimensional array to store information in it for a two-dimensional space. Pixels do that, all sorts of things. So let me come back here, and let's set that up. So what I'm going to do is I'm going to create a variable, and I'm going to call it grid, and I'm going to make it an array. Now I need to think about what is this? This pen is, by the way, very light. Can you see this? What is the size of each one of these cells in the grid? So here it says, we pick the cell size to be bounded by R divided by the square root of n. R is the minimum distance we want between our points. N is the dimensions, 2 dimensions. I mean, so interestingly enough, we could do this in 3 dimensions, or in 4 dimensions, or in, I was going to play some spacey music for 4 dimensions, but whatever. I got to work on this whole soundboard thing. I'm not very good at it. Okay, so that's something I need to calculate, and I'm going to calculate it. I'll just do it up here. I'm going to call that variable W as kind of like the width. Time out. This will get edited out. Well, hold on, I'm looking in the chat. You can barely see the green on the whiteboard. Okay, hold on. Should I? Well, I think it'll be good enough, but I won't use that green marker anymore. Where's a black one? You would think that I would be more prepared for these sorts of things. Okay, I have the black marker here. Okay, coming back. All right, this was a little edit point. Sorry. I'm gonna call that variable W to be the. I have a black marker now, by the way, so you can see this better. The size. What's the width? What's the height of each one of these cells? Okay, so I need that to be R divided by the square root of n, which is 2. So you know, you can figure that out. But you don't have to figure that out because the code will calculate that for you. Okay, so I have that. Now, so let's read this. So, okay, the grid can be implemented as a simple n-dimensional array of integers. The default -1 indicates no sample. A non-negative integer gives the index of the sample located in a cell. So basically, that big array is either going to have a -1 in it or another number in it to say like, oh, there's something in that array. So let's start by, okay, so first of all, we have to figure out how many columns are there. Because the space is 400 by 400 pixels, and the size of each one of those cells is W. So I want to have, and I want it to be an integer, so I'm going to use the floor function. I want to take the width divided by W for the number of columns, and the number of rows is the height divided by W. And then what I want to do is loop through every single spot, which is the number of columns times the number of rows, and in the grid, initialize its value to -1. So I'm starting with a grid. The idea here is the grid, you just pick up a different marker each time, where the grid is just filled with, these are the index values, but the grid itself is filled with -1, -1, -1, -1, because we're going to start actually putting points filling that grid with values. Okay, are you still, why is this still interesting to you? I hope so. Okay, so going back to this paper. Okay, good. Select the initial sample, x sub 0, whatever. What do I mean? Pick a random point. That means pick one random point, randomly chosen uniformly from the domain, insert it into the background grid, and initialize the active list. Whew. Okay, there's a bunch of extra stuff there. Okay, so forget about this active list for a second. Let's say I need to pick a random point. That's not too hard. I can pick a random point. Whoop. So let's see here. So this is really, if I'm reading the paper, this was step 0. And now I'm going to do, this by the way is no longer relevant. Now I'm going to do step 1. So which was pick a random point. Var x equals random width. Var y equals random height. And you know what? Let's make that a vector. I think it's going to be useful. A vector in P5 is an object that stores both in x and y, so I don't have to keep them as separate variables. Let's make a vector called pos with an x and the y in it. OK, we're doing well. OK, so that was, there we go. So now, select the initial sample, chosen blah, 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 insert it into the background grid. So what does that mean? So if I pick a random point somewhere in this window, oh, I got to throw a dart, right? Ready? 1, 2, 3. Ah, it worked. Exciting live demonstration. OK, so I picked this random point, and I can see that it's in spot 8. Unfortunately, I can't actually, in my code, throw something and then just see where it is. So I have to figure out where it goes. And oh, did I? Yeah, no, OK. I have to, am I back in the right place? OK. I have to now figure out where it goes. And how do I figure out where something goes? Where its column, which I'm going to call I, is the x position divided by w, right? W being the size. That's that sort of scaling factor, the size of each cell. And I also want to use the floor function to make that an integer, because it's going to be an index into an array. And then j is the y value divided by w. And so what I want to say is the grid, I plus j times the number of columns, equals that position. So this is me inserting it into the grid. I pick a random xy point. I find its column and row position. I'm saying I and j in the grid. I make a position vector out of it, and I insert it into the array. So this I plus j times columns thing, this is a formula that exists in just about so many of my code examples. But it basically is a formula for taking a column position and a row position and figuring out, if the column is 0, 1, 2, 3, and the row is 0, 1, 2, that the actual position in the array is 13. And you can see that is the column plus the row times the width. 1, 2, 3, 4, 5. So 5 times 2 is 10 plus 3 is 13. Yeah, that formula works. So that was kind of a quick explanation. I think I have a video somewhere where I go over that more. You can try to find it. OK, great. So now we have that inserted. So that's step 2. Let's go back. Oh, no, that's step 1. Sorry. So now we've done step 2. But we're missing something. Active list. So this algorithm requires an active list of points that we are currently working with. And that's going to make more sense as I get further into this. But there's some interesting stuff going on in the live chat here. OK, so let's create. I want to create another array called active. And what I want to do is also say active.push that position. So I want that position, that vector, to both be inserted into the grid. Remember, this grid is an array now that has -1 everywhere, except for this one spot that it actually has a vector. And then what I want to do is I'm going to add the draw function back in. I want to say background 0. And I just want to say, I want to loop through the grid just to make sure things are working. And I want to say stroke 255. stroke weight 4. And then I want to say, point grid index I.x, grid index I.y. However, I want to loop through the whole grid and draw all the points, but not if there's a -1 there. So I want to say, as long as grid index I does not equal to -1, then I can draw the point. So I just want to be able to see what's going on. And then also I think it would be useful to look at all the active points. So I'm also going to loop through the active array. This is really mostly for debugging, but I think it might also make kind of an interesting pattern. And I'm going to say stroke 255, 0, 255, stroke weight 4, and I'm going to draw a point, but this time at the active spot. Okay? There we go. Whoops. How's this looking, everybody? Live reload going. Let's take a look. Oh, so we have an error. Square root is not defined. Look at that. So this is, by the way, a very common P5JS problem. If you ever try to call a P5JS function outside of setup, it actually won't work because P5JS has not been initialized. The page has not been loaded until setup. This is like an on-loaded type event. I could get around that here just because it's square root by just accessing the JavaScript square root function directly. I'll just do that. Otherwise, I would have to move the square root function into setup. Col is not defined. Sketch.js line 15. This is columns times rows. There we go. OK, so you can see there's one random point. That's also one active point. And you can see each time I reload the page, it's somewhere there. OK, we're moving along here. We're trucking along here. I'm getting somewhere. Now, I think, yes, people in the chat are telling me to use a for each loop. I have nothing against for each loops, but I think it's a little bit more readable to do this right at the moment. So let me go back to this paper. And now we're going to look at step 2. This is the tofu of the algorithm, right? This is where the main stuff is happening. While the active list is not empty, choose a random index from it. OK, let's start with that. So I have to say down here, let's put step 2 at the beginning of draw. And I'm going to say while active is not while active.length is greater than 0. That's saying as long as it's not empty. Now, I'm going to make something a little bit different here. The algorithm has a while loop built into the description. In other words, it's saying, while this is true, keep doing this, keep doing this, keep doing this. But I actually don't want to do this. I want to make use of the draw loop, which animates, so I can see the algorithm animating itself. So I'm actually just going to say if, because I want to just do this one at a time. And it's going to come around and do it again with draw. So if active.length is greater than 0, what's the next thing? Choose a random index. OK, so I'm going to say var index. I'll call that r maybe. R equals random active.length. And I need to floor that. That's a random index. And then generate up to k points chosen uniformly from the spherical annulus between radius r and 2r and, oops, sorry, I don't have my. There's really no point to these sound effects. OK, OK, hold on. We're going to be OK. Let's go. Let's start with generate up to. Let's start with generate up to k points. I'm going to say for var n equals 0, n is less than k, n plus plus. So I'm going to do a loop at least k times, up to k points. And then, now this is kind of crazy. Uniformly from the spherical annulus between radius r and 2r around x index I. Let's talk about what this means. OK, so I have to find an eraser, which I'm going to use this paper towel. So here's what we have to do. This is kind of a useful thing in programming to sort of think about. I have a point that I just picked. This is my random active point. Now, there is some value in our program called r, which has this distance. OK, so r, I don't know why I wrote distance there. R has some length. So what I want to do is pick another point around this point whose distance is somewhere randomly between r and 2r. So in other words, I want to pick any point that's within kind of this donut, right? I don't want it to be, it can't be within R, otherwise it's invalid. And I don't want it to be really far away. I want it to be between R and 2R. So how do I do that? Well, one thing I could do is just pick a random angle, right? First, let me pick a random angle, and then let me pick a random value between R and 2R, and I want to place the point offset from here along that angle, somewhere between R and 2R. So that's what I need to do. So let's come back to the code. And what I want to do is say, so first I want to angle, random to pi. Honestly, here's the thing. I could take some, let me do it long-windedly, but I could take some shortcuts because there's some functions in P5 that would sort of do some of these steps for me. But then I want to create the offset values. So offset x is cosine of that angle. Offset y is sine of that angle, right? This is trigonometry that if I have an angle, I can get the sides of the triangle, right, from that angle with cosine and sine. Look for one of my video tutorials that goes through this math. So, but actually, what I can actually do, by the way, is just pick a random vector. So all of this, really what I want to do is say var offset equals p5.vector.random2d. Because what that's going to give me is a random unit vector pointing in some direction from here. And then all I want to do is make the length of that vector between R and 2R. So now I want to create a magnitude, which is some random value between R and 2 times R. And then I want to take the offset and set the offset's magnitude to that random value. And then where's the point? That point, actually, I can just say offset add. Oh, wait, I forgot to get it. So the position that I'm working with is from the active array, that particular, so I remember I'm picking a random point from the active array, and then up to k times, 30 times, I'm going to pick random points around it between what? Between R and 2R. So now if I add position to that offset, this is really the point. And actually, here's what I'm going to do. I'm going to change my variable naming a little bit. What I'm trying to do is make a new sample. So I'm going to call this sample, and I'm going to make a random vector, and then sample is going to get the position added to it. So now that's that actual point. So I'm now done with this particular step. Generate up to k points. I've done one point uniformly between R and 2R. For each point, check if it is within distance, oh wait, there's a mouse in the way. Check if it is within distance R of existing samples using the background grid to only test nearby samples. This is an exciting moment, okay? I don't know if anyone is still watching this video however many minutes in. I might be like 20 minutes in already. This is like a video about Poisson disc point picking, but this is a moment because what I'm going to do here actually applies to a lot of other scenarios. Let's think about this for a second. I want to talk about what's going on. Let me find my marker. Let me find my paper towel. Okay, let me come over here. So let's think about this. There is a space, and that space is full of points. And I am working with a particular new point right here. And let's say I want to know, is this point too close to any of the points in the space? Most algorithms would say, I have to check this point against every other point in the space. And there could be, something like 10 million points in a space. And this could take a long time, especially I'm doing this as part of some animation algorithm. However, the whole point of this Poisson disc thing that we're doing is that the points are registered to a spot on some kind of grid. And if the only thing I care about is a point too close to another point, if this point is within this spot on the grid, I kind of know 100% that I don't need to check these points, or these points, or these points. The only ones that are worth checking are the ones that are in immediate neighboring spots on the grid. And this allows a massive savings in performance. And in a flocking simulation, in a collision detection simulation, this kind of algorithm can also be used. And it's quad tree type stuff. I'll do some other videos on that at some point. But so let's look at how we're going to do that here. Okay, now So what I need to do is check. I want to check. OK, so first of all, I need to know where is this point in the grid. So I need to know its column position is sample.x divided by w. And I need to floor that. So this is where it's going to be in the grid. Then I need to know its row position, which is sample.y divided by w. And then I need to do another loop. Like I could check each neighbor individually, but let's do another loop, right? Nested loop. I starts at -1, which is like the spot to the left. I is less than or equal to 1, which is the spot to the right. I plus plus. And then j is equal to -1. Same thing. J is less than 1. J plus plus. And then what I want to do is I want to look at a point. I don't know what to call it. Neighbor. I'll call it neighbor equals the grid at I plus j times the number of columns. And I want to check the distance now between the sample. The distance between, and I can use the p5 vector distance function. The distance between the sample and the neighbor. And I want to do something. Right? This is going to, if that distance is less than r. Right? The whole point of this whole thing that we're doing is to make all these points on the screen where none of them are within this distance threshold. Okay? So this is very key right here. What do I do if I find one by accident that's too close to? So let me go back to this and see. For each point in turn, check if it is within distance r. Okay? If a point is adequately far from existing samples, then it goes into the active list and it's good. OK, so we're trying to find, at 30 times we're going to try to find a point that's OK. So here what I think would work best is for me to create a Boolean variable like, I'm going to call it OK. And I'm going to assume it's OK. Var OK is true. It's going to be OK. However, if that distance is ever less than r, it's not OK anymore. So I got to check everything. Now here's a problem. I don't want to check. Here's another. First of all, there might be nothing in the grid. So I only want to do this if the neighbor is not equal to -1. Remember, -1. There's probably a different way. I might clean this code up later. famous words of every single programmer ever. I might clean this code up later. Here, remember. If something's not actually in the grid, we're just sticking a -1 in the array. So I only want to do this, right, if -1. If there's nothing there, it's definitely not too close because there's nothing there to be too close to. So, OK, so after I do this, I want to check and say, after all of this, if it's OK, what do I want to do? I want the grid at that spot to be that sample. And I want I want to add that sample to active. So remember, I'm keeping two lists. I'm keeping an array of this grid. So I want to put the point in the grid, but I also want to put it in the active list because it's going to be another point that we could use later to pick a point next to it. OK. Boy, there's OK. So now let's think. I feel like there's some sort of missing issue here. There's kind of an issue. What if I think I need to check. It's not written in. Let's keep reading the paper. OK, emit as the next. OK, so let me. I feel like I missed a step here that isn't explicitly written here, but I'm going to keep going with what's written here. So OK, so one thing we should do is say like, well, if it's OK. Remember, I'm in this loop to try this k times. If I find a point, I don't need to keep trying. So, or should I keep trying? Generate up to k points. I guess I could keep trying. But I do need to check. I do need to figure out if I get to k and I haven't found a point, then at least one point, then I need to remove this active one. So let's create a variable called found is false. So I'm assuming I'm going to try now k times. If I find something, I'm going to set found equal to true. Here is where I know I found something. So I'm going to say found equals true. And then what I'm also going to do now is if I get to the end of this loop k, boy, there's a lot of code here. If it's not found, what do I want to do? Active.splice r, 1. right? Remember, the whole point is I started with a random point in the active list, and I tried to find points around it that are OK. If I didn't find any points around it that are OK, I want to take that point out of the list. And splice is a JavaScript function that removes an element from an array. Splice at the index r. Oh boy, there's a big problem here, right? I've used r as the variable name for that minimum distance threshold. And then I just made a new variable r for that index. So I'm going to rename this to rand index. Let's use a better variable name, rand index, and then go back and add that here. OK, I can't believe I've written so much code without running it. It's a terrible idea, actually. I generally try to avoid doing this. Yeah, Taylor in the chat says, can't you break after OK equals false? I think actually after OK is true. Yeah, so I was going to put a break here. Let's comment this out and see how it works with or without it. Let's just put a little question here. Should we break? Oh, we'll discuss that later. So weirdly, I kind of have all of the code right now, right? If we go back and look at this, we're done. Now, but I know that in my head, there's something that I'm missing. Let's see if you can think about what I'm missing. But let's actually just try running it. Well, nothing's happening. You know, which is not surprising. I'm surprised that I'm not seeing anything at all, actually. Oh, the camera went off. OK, well, this can be an edit point anyway. Mathieu, who's maybe watching, I'm going to make this an edit point too. Yeah. Danish in the chat asks, can anybody tell me what he's trying to make? And apparently, you are correct. Bacon, someone in the chat named Bacon, a pink dot. Half an hour of programming, and we have a pink dot. OK, so I'm thinking here, what could be, I just want to look here for a second. JavaScript is so not interested in giving me errors. There's definitely a problem. I'm surprised that I didn't get that. You know what I could do? So I'm going to get index out of bounds errors. That's one thing that's an issue. Oh, yes, thank you, thank you, thank you, thank you, thank you, Nextricate. OK, so that's certainly a big mistake that I had there. So I'm recalibrating this fan. OK, so anyway, I'm going to come back into the tutorial now. OK, so there's a bunch of errors in my code, one of which is quite crucial, is that actually this here is absolutely wrong. What I'm looking for, right, this nested loop where I'm trying to find the neighbors, I need to add the actual place that I'm at. So this should actually be column plus I plus, and I kind of hate the way that I've written this, row plus j times columns, but we'll leave it. You know, I think I might like to say something like this, just to kind of put this in a separate variable, like calculate that index this way. OK, so that was something I definitely was missing. So that's the thing I'm definitely missing. Let's see if we can kind of debug this a little bit. And actually, there's something else that I feel like I'm missing, which is sort of crucial, which is that if I pick a point, and let's add the break there. Maybe the break is a bit of a problem. Let's see if things are going. Whoa, OK. OK, pause. Or don't pause. I'm going to do some debugging now. Oh, you know what? It got stuck at one point in an infinite loop. You can see, if you ever see this, like the page, I probably shouldn't use this live reload thing. Look, you can see this tab is crashed. Cols is not defined. Sketch line 48. Look at this. I have these I didn't make global variables. So that's a bit of a problem. Wait, hold on. I don't know if that should be edited out. But I'm going to go back into it as if there was like an edit point there to kind of like shorten this when I publish this as a standalone video. OK, I'm going to come back. Let's check the code. Oh, cols is not defined. OK, so oops, one thing that I forgot is that if I'm going to use these in setup or draw, they need to be global variables. So let's do that. Okay, oh, look at this. Amazingly, it's actually working. I kind of thought for sure I had a problem. Yeah, okay, great. So we have an error, uncaught cannot read property copy of undefined. Let's see if we can, the distance function in draw, sketch.js line 52. So we have a problem here, and I think I know, this is what I was thinking of here, that if neighbor does not equal -1, well, guess what neighbor could also be? Could neighbor ever be, or could sample be undefined? I'm trying to think about this. Well, to me, there's an issue here, and I don't know if this is what I'm thinking. Okay, this is what I'm thinking. I'm thinking that this new point that I've picked, if grid, oh, I know what it is, of course. So there's definitely a major issue here, which is that if neighbor does not equal -1, or if neighbor, I think I could just say if not neighbor. And you know what? You know what would be better? Let's not even, because I could just fill it with undefined. Because undefined in JavaScript evaluates to false. And then, was there another place that I was checking -1? And then I can just also say if not grid index I, which I think is a better way to do it. The reason why I want to do this is sometimes going to give me, what if I'm on the edge, right? If I'm in the cell on the edge and I try to look to neighbor -1, it's going to be undefined. So I also need to check for that. And if I come back over here, did I switch to the other screen there? I don't know if I did. So I'm still getting this issue. Okay. Okay. What happened here? Sketch line 52. So let's look at what the value of neighbor is. Undefined. Oh, if neighbor. I only want to do this not if not neighbor, if neighbor. Cannot read property X of undefined, line 78. If, only if, not if not, only if. Boy, here we go. Now we can start to see this working. And we're getting this distribution. Now, I kind of thought that I needed another check, but I'm kind of amazed that this is working anyway. I guess I don't need that other check. And you can see which points are active and which points are finished. And we can, let's just let this finish. It should get, now, the reason why you're not seeing this happen really, really fast is because I'm doing it once per frame, and P5 only runs like 30 frames or 60 frames per second. But I could now a couple things I want to check. One, I want to take this console log out. One thing I'm just curious, what happens if I take out this break? Yeah, then we can find multiple points per frame. So if I'm checking for 30 points around a point, then I'm finding multiple points per frame. Doesn't really make a difference. I kind of like the animation better when I am enforcing just 1 point per frame. And look at that, starting from the bottom now. But something that I want to add here just to show you is I'm going to change this to a while loop. And look at this. So there is an issue with the code, which is that what happens when it's not finishing correctly. So I need to figure this out. Right, so Taylor S. is asking this question, how quick is it if it runs entirely in one frame? And this is not working right now. And I even crashed the... So let's think about this. Why is this not working? So I think there's an issue. This is an issue that I'm thinking of. When I pick... I know what the problem is. What if I pick this sample point and there already exists a point in that spot in the grid? I could be stuck in an infinite loop because I could continuously just keep picking a new sample point. If the grid is ever full, I don't want to pick points anymore. So I think that I should add a check, right? If grid column plus row times the columns, right? If it exists, then I don't, right? If something already exists there, then also skip everything? Hold on a sec, I'm thinking. Right, let me think about this for a second. More. Pause. Wait a sec. Okay, let me think about this. Right, I just picked a new sample, and a sample already exists there. Found is going to be, I don't want found to be able to be true. So I should just skip this whole thing. That point is no good. Okay. So I can put that around there. Yeah, that's definitely going to be right. So, sorry, I meant to, oops. I have to go back into this video. Right, is this what it was? If, let me think about this. Remove, oh, hold on. Let's put it back to if. I got to get this right, and then we'll edit back into the video. So now I only have 1 point. Why is that? The sample, the new sample that I picked should be in a new spot. No. Am I picking by accident in the same? I'm just curious. Just want to do this for a second. No, what did I miss? Okay, hold on. We're going to figure this out, everybody. This last little piece. Okay, right, that works. Why? Right, let's look at this. Oh, no. I'm always doing this. This needs to be a not. If it doesn't exist, go ahead. There we go. Okay, hold on. I got to go back into the video, because now I should be able to put a while here. No, infinite loop still. Okay, hold on. What's happening at the end? Boy, this is a much more complex problem than I imagined. Okay, so this is working. Let's let it do this. Oh, no, not while here. The while goes here, right? No? Did I do that right? Okay, hold on, everybody. Let's have this do it. I want to do 10. Oh, hold on. Let's make the space between them bigger and the canvas really small. So what's happening at the end? So let's look at the active array. Things aren't getting removed from the active array, it seems. Yeah, look at that. Maybe while active.length is greater than no, if it's empty, I want to stop. Let's just agree Java is better. Why are there so many points in the active array? All right, let's think about this. Where am I removing stuff? If not found, found is false. All right, let's do this. Also, how are there so many points? Where do I... no, if it goes to the end, the index would stay the same. Okay, hold on. Yeah, that's weird. So let me make the frame rate 1. let's look at this. A little more closely. Look at this. It's adding points somewhere that I can't see. So let's look at sample is always a new vector, right? This was going so well until I ran into this problem. It's interesting how it's working, but it's just not finishing. It's got all this extra stuff in there that's unnecessary. Just look at the sequence here. Add, 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 add. So what are those points? What's being added when I can't see something? Add, add, add. Yeah, look, here's a point off. Hold on, hold on, hold on. Stop, stop, stop. How do I stop? No, oops. No loop. Why are there points being generated off screen? Oh, 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 oh. So points should be invalid. I've got to check. Because of the way JavaScript is, okay. Okay. I think I know what's going on. Yeah, you know, I always forget this about JavaScript. JavaScript, I would get an error if I tried to put a point in the grid. It doesn't exist. It's actually just, the space is expanding beyond what we can see. Because it's just like, the array is not a fixed length. It's so funny. I mean, not so, okay. I have to think about how to solve this. And then this video gets, this whole thinking part's going to be edited out. I'm going to start with the debugging. Let's look at the code. Boy. Oh, JavaScript. Oh, JavaScript. Okay. This is the problem. Here, this point is invalid if it's off screen. Okay? So that's actually should be, yeah, JS array is a dynamic array. So, in addition to checking if it doesn't exist, it can exist or be off the screen. So it can exist or column. It was just expanding forever, which is kind of interesting, but not what we want. Okay. Okay, so I'm going to go back into this video, and I think I can fix this. I'm trying to decide if I want to. Okay, so let me. I just want to take this out. Okay, and okay. All right, so okay, I'm back, and to debug this, which I just did, and you can find the live stream version of this if you want to see that about like 15 minutes of me figuring this out. I've changed the frame rate to 1, and I'm looking now and seeing like, whoa, why is it generating all of these positions that are like way off screen, like -16 and -68? Those aren't valid points in my space. And I always forget that a JavaScript array is this dynamic thing. So it has no problem just saying like, oh, okay, you're generating points off the screen. I'm just going to keep adding them as opposed to giving me something like an index out of bounds exception, like, oh, you generated a point that's not part of your original grid. So I need to protect against that in some way. And the way that I think I could do that right here is in the same way that I am checking to make sure that this is not, that this is a spot that's not already filled. What I can also check is that column. I want to make sure that column is less than columns. And I only can go forward if the column is actually on the screen and row is less than the total rows and it is a spot that is empty. So that, if I add that in, we should be able to watch this now. And if I run this, I shouldn't see any points being generated off screen. So let's look and see if this is working now. I'm going to console log the length of the active array. And I'm going to get rid of console logging where that point is. And I'm going to put the frame rate back. And I'm going to run it again. And we should see, okay, timeout. I got closer. I still have points off screen. So maybe, oh, greater than 0, yeah. Okay, also, oh my God, so many things to check. I also have to make sure it's greater than, all right. I can't just check if it's not. I'm going to just give myself a clean edit point. Obviously, I only checked, not obviously, because apparently not obviously to me, I only checked if it was off the right-hand side or the bottom. So I need to also check if it's greater than 0, or if it is, or if it's greater than, and actually 0 is perfectly valid, so greater than -1. I could say greater than or equal to 0, all of these as well. This is a very awkward if statement, so maybe I can figure out a better way to write that at some point. And now you can see, there we go, active got down to 0. And you can see how it fills up rather quickly. So let's go back now. And I'm going to comment this out. I'm going to make the screen again 400 by 400. And I am going to give myself some more space to see this in. I'm going to make R back down to like 10. And I'm going to run it. And you can see now here it is filling the entire window. Now let's just see if I actually put in a while loop here in draw. And I can also say no loop, so it only does it once. And you can see, boom. Each time I refresh, you can see I get a completely different distribution. Very, very fast. And I could make this even higher resolution. I'm going to get this image very, very fast. I do kind of like watching it grow, though. So let's see if we can make something a little prettier out of this. So one is we see the active points and the non-active points, which is kind of interesting to see. One thing that I might be curious to do is change that R to like 4. And change the stroke weight to 1. And then also, I think what could be interesting is let's actually have it pick more than 1 point per frame. So I'm gonna say for var total equals 0, total is less than 5, total plus plus. So this, I'm just gonna do this whole thing 5 times per frame. I don't want to draw everything 5 times per frame. And we can see now, you can see it growing kind of faster. Ooh, look at this. I have a stroke weight 4 somewhere else. And you can see, look at this kind of spacey thing growing. I think it's even actually kind of beautiful. Let's make this, I mean, you can now stop watching this video and go and grab my code and play around with this. But I could do like 25 at a time. It's kind of nice to watch it grow. You know, I could even make that R like 2. And you can see, look at this kind of amazing, what I'm getting, that you can kind of pattern. And then I could also think about what if, as I'm drawing these points, I did something like I said, color mode HSB. And I used the color to be, so this is just the active. Let's get rid of the active points for a second. What if I said the color is I modulus 360. 255, oh, 100, 100, I think are the defaults. So you can see something interesting happening here. And maybe I should say something like I divided by 100 You can see I kind of am getting this rainbow pattern out of the growth of points. So that's interesting. This is not what I was expecting. Because I'm doing it based on where they are in the grid, not their order of when they were added. So you know what I would need to do? So people are making great suggestions in the chat, which I would like to. This video needs to be over soon. So this, by the way, is just giving you, you're just seeing the stripes because it's just drawing them according to the grid pattern. But what I want to actually do is have their order. So let's have another array. I'm sure there's which I'm going to call it ordered. And every time I add a sample to the grid, a valid sample, I'm going to say ordered.push sample. So I'm just going to make a separate array that just has them in order. And then actually what I would like to do is draw them based on the order. And whoops, and I need to do this as well. Ordered, I called it ordered, I think, right? So if I add this now, we can see, and I don't need that divide by 100 anymore. You can see now their color is according to when they were created. And this is a bit too, too extreme. And you know what might be nice, by the way, is to just have my stroke weight be R. Because then you can see, there we go. And let's, you know what, just so I can see this more consistently, let's add, always start the point not random, but actually have the first point just be in the middle. And there we go. OK, so now we have fast, animated, Poisson, disk pointing, evenly distributed. And one of the suggestions, and really actually, unfortunately, the way that I've written this, because of the way that this should really be divided by 2 or times 0.5. There we go. So that way they won't be overlapping. So you can see this is kind of an interesting algorithm for seeding these points. Somebody in the chat, yes, I am addicted to HSB. You know, I'm going with the rainbow theme. If somebody, I should really think of a different way of doing it, but it's my theme. So if somebody suggested, and this is an interesting thing to think about, how could you start with larger points and then slowly over time have smaller points and have that distance threshold be something that's variable and that grid be something that's variable? That's kind of probably quite a complex problem which I would like to think about and do future videos on. OK, so thanks for watching this video about Poisson distribution of points in a 2-dimensional plane. See if you can expand this into 3 dimensions. See if you can change the sizes of these, find a different way to color them. Use this as a way of seeding another type of system. And whatever creative possibilities you build out of this, build from the code that you'll find in this video's description, and keep me posted and share on Twitter or wherever you can share it. And I'm excited to see what you make. OK, goodbye. Wow, that was kind of way longer than I ever expected, which just goes to show you if I don't practice these things in advance, I don't really know how long it's going to take. It is 12:20. I definitely want to do more today. So things that I'm thinking about. Are okay, here, this one we could definitely do quickly. This is a possibility. I feel like we should probably do this one. Oh yeah, let's do this one. Because look how similar this looks. In an interesting way. Maybe we should do this one. Look, HSB, right? I think probably this one. There was one other thing that I was thinking about. Oh, traveling salesperson. Right, we could apply the traveling salesperson to those points. I really want to do that. I need some energy. I'm feeling quite tired. don't know if this will help. Oh, there's 82 people watching right now. Really? That's crazy. What other music do I have? I'll give you a sneak preview of the theme song. This is just a sneak preview.
Ride the colors of code. You can follow the road to coding rainbow.
Okay, that's my quick sneak preview. Everyone spam Agario. Sorry, Limit ZA. I should say that I think I used YouTube's like standard words of standard list of words to immediately block somebody in the chat. So if you use certain words in the chat, I apologize. Okay. Okay, I'm looking to see if anyone's, yeah, Agario's not going to happen today. I know you guys, I did the beginning of it. Oh, question time. Yeah, you could ask some questions now. Okay, so I'm thinking it is 12:20. I think I've got, you know, I'm a little bit losing energy. Computer craft. Yeah, I really want to do computer craft. Yeah, I'm not prepared for that. Yeah, so I'll mention, by the way, all of you have asked about. So first of all, I've done a whole series, about 10 videos on genetic algorithms. About half of them have been published. You can find the rest of it in the live stream archives. But those videos are machine learning. So genetic algorithms is an algorithm to use uses the evolutionary process for a system to learn something, to adapt over time. It's an adaptive process. The machine learning stuff is probably going to come more in the fall. But you can, two things you can do if you want to kind of stay up to date on what I'm thinking. I'll go to. I'm going to go to sort by most requested, which is clearly machine learning. I did a pass over my outline. So the very first, this is the set of videos that I'm going to make, and I'm also writing a new chapter to the Nature of Code book that will go not through all of this. But I want to start, I think, with just basics of classification. I think I want to implement this thing called k-nearest neighbor, like from scratch, and then show how a library would do it more efficiently, and look at the basics of neural networks. And I've been looking also at a library called Deep Learning 4J, which is a Java-based deep learning library, which I can use with processing to do some deep learning stuff with images or shapes. And so please, at this GitHub issue thread, send me your ideas for example applications or particular libraries that I might look at. That could be useful. Yeah, the whiteboard is peeking in. I will fix that. So that's one thing I'll mention about machine learning stuff. There was something else that I was going to say that somebody had asked about. Titus in the chat asked, could you create a video how exactly Perlin-Noyes algorithm works? I have that video already. Go look for my Perlin-Noyes playlist. So there's a playlist of 5 or 6 videos about Perlin-Noyes and how it works. Okay. So automated snake game. Yeah, okay. I'm looking back and forth. Computer craft. Yeah, okay. Somebody had asked something else. All right, so let's see here. I think what I am going to do is finish off today with another coding challenge to make. I would like to see this in my JavaScript window. This one's not going to be so easy, I have to say. I thought the other one, by the way, was going to be really easy. Or easy is the wrong word, but I thought the other one was going to take me very little time. Amazingly, it took quite a bit longer than I thought. I'm tempted to do this though, so tempted. But this is going to take too long. So hard to decide. I should definitely always decide in advance. So I'm looking at the chat. Yeah, interesting. It does look. It's interesting how it looks so similar to the last one. So let's do it. Okay. So this is, I'm going to finish off with this today and answer some more questions at the end. Let me get myself ready here. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot. So this is this dot. dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody compose that song for me. I'm resting my voice. Just trying to get ready for the next challenge. Okay. Oh, F Looper asks why you never play my this dot song. Well, okay. That's a very good question. And I don't have a, whoops. I don't have a good reason for it other than when I made the soundboard, I had 2 this dot songs and 1 Pearl and Noise song. And so since they were by 2 different people, I took the this dot from the other person. I took the Pearl and Noise one from you, which is
So this is random, this is noise, Pearl and Noise that is, in the core.
But I should add your this
algorithm,
dot song here as
actual
well.
random algorithm itself, those numbers aren't related at all. You pick, like, I'm picking random numbers between 0 and 10. 9, 2, 7, 6, 1, 9,
Okay.
4, 8, 9, 2, 1, 3. I pick 9 a lot apparently. But with Pearl and Noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5, 6, 7, 8, 9, 8, 7,
Okay.
6. Boy, this is like
thinking
Pearl
about
and
this.
Noise performance art. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1.
I'm thinking. My brain is working here.
2, 3,
Look at
4,
these.
3, 4, 5, 6, 5, 4. Boy, this is like Pearl and Noise performance art. 7, 5, 9, 2, 7, 6, 1, 9, 4, 8. But with Pearl and Noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5,
Okay.
6, 7, 5, 6, 7, 5. Pearl and Noise, that is. Pearl and Noise. So this is Pearl and Noise, that is. Pearl and Noise. This is Pearl and Noise, that is. Pearl and Noise. So this is Pearl and Noise, that is. Pearl and Noise. Pearl and Noise, that is. Pearl and Noise. So this is Pearl and Noise, that is. Pearl and Noise. This is Pearl and Noise, that is. Pearl and Noise. So this is Pearl and Noise, that is. Pearl and Noise.
Pearl and Noise, that is. Pearl and Noise. So this is Pearl and Noise, that is. Pearl and Noise. This is Pearl and Noise, that is. Pearl and Noise. So this is Pearl and Noise, that is. Pearl and Noise. Pearl and Noise, that is. Pearl and Noise. This is Pearl and Noise, that is. Pearl and Noise. This is Pearl and Noise, that is. Pearl and Noise. So this is Pearl and Noise, that is. Pearl and Noise.
Apparently. But with Pearl and Noise, I might pick numbers like this. 2, 3, 4, 3, 4,
How are we doing?
5, 6, 5, 4,
Okay.
6, 7, 5, 6, 7, 5, 2, 3, 4, 3, 4, 5, 6, 5, 4, 5.
Hello. Have a bell.
7, 5. Boy, this is like Pearl and Noise performance art.
All right. I'm getting ready to now do a particular video on the algorithm. I'm looking for a tissue. I feel like I need to blow my nose, so I'm going to step over here to do that. I'm going to mute my microphone. I'll give you a little sampling of the theme song again.
Ride the colors of code. You can follow the road to coding rainbow.
All right, so here we are. I'm asked, at what age did I start programming? Okay, well, I don't want to get too lost in this story here, but I'll give you a multi-part answer to that question. I believe I first did programming in the basic programming language on an Apple IIc, somewhere in a like sort of elementary school kind of age. I also remember in middle school, in like seventh grade, I did some assembly language and some more basic programming, and then that was it. And then I didn't actually program again until, I want to say age 30, if you can believe that. So I actually really only learned to program at like, no, 27, what, I have to do the math here. It's so hard, 28. I was 27 or 28. Okay, now that I've admitted that, I wasted a lot of years. Although, actually, I think not programming anyway, diffusion-limited aggregation. Okay, here we go.
Ride the colors of code. You can follow the road to coding rainbow.
Okay. Let's see. Here we go. This is going to be my last coding challenge for today. I need to move this over here, move this over here. I want to cycle the cameras. This is one that I really, really feel like I should have done, practiced in advance. Now I have, especially if I'm going to do this in JavaScript but I think I'll do this one in JavaScript. Okay, here we go. So people are asking about the theme song. So the theme song is completed, and I'm working on, I'm not actually, with collaborating with some friends and colleagues, working on a music video, which is a lot of weird green screen footage. By the way, if you're interested, I'm looking for animations and colorful things made with processing or P5 that could maybe make their way into the music video as part of the backgrounds or the foregrounds. So if you're interested in submitting something, you can, I would say tweet me at Schiffman is probably the best way. Okay, here we go. Let's get started. It's 12:34. I think I have maximum an hour. I need to eat lunch. I have something to do at 1:30, which is an hour from now. So I would like to be done before that, but let's see how it goes. Okay. Here we go. There's too much going on in the chat. I can't follow it any longer. Okay. So here we go. I'm going to try starting this video with a bumper music. Hello, and welcome to another coding challenge. This one is diffusion-limited aggregation. Okay, so diffusion-limited aggregation is an algorithm. It's an algorithm where I gotta try this again. I'm thinking about it. Brownian trees, fractal, yada yada yada. Let's look at what Paul Bork says. Yeah, electrolyte solution, zinc ions, diffusion. Whoa! Oh my goodness! Look at this. How interesting. Okay, let's start over. So I'm going to definitely need the whiteboard for this. Get myself ready. Okay. Let's see if I can make this happen. Okay. Welcome to another coding challenge. In this coding challenge, I'm going to tackle diffusion-limited aggregation. So what is diffusion-limited aggregation? Well, I encourage you to take a look at two references. There's always, of course, a Wikipedia page. You can kind of find out a little bit about the history of this algorithm, how it was thought of, what it's applied to, what it kind of what it can be used for. The reference that I'm using here that I read right before making this video, or actually earlier this morning, a couple hours ago at this point, is a page on the internet from June 1991 written by Paul Bork, which describes the algorithm. You can see that diffusion describes, among other things, the diffusion of the aggregation of zinc ions in an electrolytic solution. Ooh, that sounds kind of exciting. But anyway, the point of what we can do with this algorithm is to create certain kinds of fractal-like, tree-like, crystal-like growth patterns, and you can see there's a variety of possibilities, and there's one down here that I particularly like, this one, which I might try to recreate by the end of this video. But let me, rather than read to you, as much as you might enjoy me just reading that webpage to you in this video, why don't I describe to you a little bit about how this algorithm works? At least how I think it works, and then the internet can always correct me. And once I start to write the code for it, we'll see if I'm thinking about it correctly. Because honestly, I don't know. I should have practiced this in advance. Something is definitely going to go wrong in this video. Okay, so let's say we pick a point at the middle of the screen. And then we just say, oh, hello. I don't know who we're saying hello to. But there's this thing called a random walker. And the random walker starts here, just starts to randomly move around the screen. And at some point, it hits this point. Now, obviously, it's not going to take that exact path, although it could randomly. And once it hits an existing point, it gets stuck. And then we release a new random walker, and it starts to walk around. And when it hits an existing point, it also gets stuck. And then we release another random walker, and it gets stuck. And another one gets stuck, and another one gets stuck, and another one gets stuck. And as they get stuck, we start to see this fanning out pattern. So this is what I want to do. Now, I think it would be really interesting to actually animate the full process. There's kind of a spectrum here. We could write code to animate the whole thing, like we see these random walkers moving around the screen and getting stuck. We could also not animate anything and just see the final image. Or we could do something in between. I think I'm going to try to do point by point, but not animate the random walk itself. That's what I'm going to attempt. So let's go back over, and we need some code to start with, which I have here. No code. I mean, I have a P5.js sketch with a canvas and a background. And if I go back to the browser, I think I have it running here. In the browser, I can open up the console, which I'm definitely going to need for debugging. And so let's first start. What do I need? I think I want to have an object. No, you know what? Let's just start right now first. Let's do this rather simply. I'm going to say, I'm going to call the thing that's finished the tree. I don't know if that's a good name for it, but all of the points that are in the pattern, I'm going to call the tree. I'm going to need a walker, the point that's moving around. And that's just about it, really. And what I want to do is, and I need a size, like the radius for each one of these points, which, by the way, you could do it on a per pixel basis, so that always could be 1. But I'm going to try something like 16, just to have it be bigger to start with. So the first thing I'm going to do is I'm going to say tree index 0 equals create vector, a point in the middle of the window. And then what I'm going to do in draw is I'm going to say for all the points in the tree, say stroke weight r and stroke 255, and I'm just going to draw a point tree index I dot x, tree index I dot y. So and let's not worry about this walker for a second. So I'm going to refresh it. Well, OK, but I don't need to refresh it. It's live. I'm using this Addendum package called live reload. So there's the point. OK, so now what I want to do is I want to create something that I'm going to call a walker. And I'm going to create it. I don't know if this is such a good idea, but I'm just going to put it completely randomly anywhere in the sketch window. It probably should start along the edge or something, or actually if you read Paul Bork's page, I remember now reading a point that you can make the algorithm more efficient by cleverly picking it close to where you think it might need to be. But I'm just going to create a random walker, and I'm going to say, I'm going to see if that walker should be stuck. So first thing I need to do is check again all of the points of the tree, and I want to know the distance between that walker and a particular point in the tree. And if that distance is less than some threshold, r, I guess. Oh no, r times 2, right? Because I just want to know if those two circles are touching. So if the two circles are touching, the distance is less than twice their radius. If distance is less than r, then stuck equals true. So I'm going to create a Boolean variable, assuming stuck is false. And then I'm going to go through all of the points. And if stuck is true, I can say break. And now what do I do here? I'm going to say, and actually what I want to do is like keep going until you get stuck. So as long as you're not stuck, keep checking all of the points. And as soon as you get stuck, set stuck equal to true. And what happens if you get through this loop and you're still not stuck? Then walker should randomly walk by some amount. And I could probably be more thoughtful about this. Walker.x should change and walker.y should change. The other thing I really need to do is I should make sure it stays on the, I don't want it to walk randomly far, far away off the window. So I should constrain it to between 0 and the width of the window. So let's see, and now, once it finds a point when it's stuck, then what do? I say tree.push walker. There we go. And now let's see what happens here. So I've got some infinite loop problem. This always happens. With live reload, I shouldn't be like, there we go. Oh, look at that. So I messed up. Something good is happening, but boy, did I mess something up. This is interesting. So I must have used an X and a Y. Ah, OK. That should help. Yeah. So interestingly enough, this doesn't look so totally crazy. Is this correct, though? Very hard to tell. So let's do a couple things. One is the stroke weight should really be half the radius. And they should be right up against each other. Let's move it by just, one thing I want to do is create, I'm gonna just make a random unit vector to be a little bit more controlled about how they're moving. And then I'm just going to say walker.add that velocity. So this is a little bit better just to make a random vector and add that to the walker. I think this live reload thing doesn't work for me because okay, that's good. And actually, maybe I meant for this to be ×2. Yeah, there we go. OK, so this is definitely looking kind of right now. The basic idea. Let's make this much smaller. Yeah. So you can see this is actually working, although it's quite of a slow algorithm. You can speed this up. So I think I've got the basics of the algorithm correct, actually. It's just kind of slow to do this one point at a time. Let's do it this way. One thing I want to do, wow, maybe this isn't as bad as I thought. Let's think about this. Let's do, I think we could release a bunch of walkers at a time. So let's try, releasing 10 walkers at a time. And just to see if we can kind of get this going a little bit faster. Oh, you know what? The walkers, I think, need to start from an outside point. Right? Well, let me do this, though, anyway. And then we're going to pick where the walkers start differently, which is going to be much better, I think. So, all right. So I just want to see something. I'm going to create a bunch of these walkers. And then now, actually, I can just do this as a loop, right? While you're not stuck. OK, if. Hold on. Just pause for a second. Boy, this is really hard to be doing like 2 hours into today without having very much not slept very well. What I was thinking I was going to be clever was like add a whole bunch around the edges and have them all just like kind of start walking and then remove them as they're done. And I think I really need a walker object to do that. So let me, this is why I want to practice these things in advance to think them through. Thinking about the best, most efficient way to do this. Create vector, by the way, people are, someone is asking in the chat, Akash is asking, create vector creates a P5 vector object, which stores both an X and a Y. Okay, so hold on. I'm back, and I thought of something which I think it might make a little bit more sense to be able to play with this a bit more by having the walker itself be an object. So I would like the, instead of just being a vector, I want it to be an object that can store both where it is on the screen, its size, I can call functions on it. That's going to give us more ways of playing with this algorithm and make it perhaps a bit more efficient. So let me go here, and what I'm going to do is I'm going to create a new file, and I'm going to call that file walker.js, and I'm going to make a walker object, a constructor function, and I'm going to say this dot position equals create vector, random width, random height. So I just want to take a lot of this functionality and that I've written out here, and I want to also, I want to create a variable called this dot stuck, and I want that variable to be false when it starts. I want to have a function that's called walk. So I want to I want to have a function. I want to have a function called walk where I implement this algorithm where I pick a random vector, I add it to the walker so it moves somewhere on the screen. I constrain where it is in the window. And I want to have a function that says check. What's a better name for that function? Like update? No, stick. I can't think of a good name. Whatever. Check sticky. Check stuck. Whatever. That's going to be the name of the function. Check stuck. And in that function, what I'm going to do is I'm going to take this particular algorithm. And I am going to, and I actually kind of want to see them walk, but I think I have I actually kind of want to do this without the while loop. So what I want to, for a second, what I want to do is check all of the points on the tree and see if the distance between this walker's position, right, which is actually this dot pos now dot, right, the walker is now an object with a position, is near anything that's in the tree's position, because everything in the tree are walkers that are stuck. Oh, you know what I didn't do is I'm not delete, anyway, so okay, keep, so, and then if it's stuck, I'm going to do something, obviously. Okay, so what I want to do here now is create an array of walkers. And actually, tree index 0 is going to be a new walker that is in the middle of the window, and that is stuck. So what I'm going to do in the object is I'm going to have some optional arguments. I'm going to say x, y, stuck, and I'm going to say I'm going to say x. I'm going to say x, or this is a way of doing optional arguments. So if I pass in an x, I'm going to create the vector at that x. But if I don't, x will be undefined, and I'll get a random value. Y or random height. Okay, and then same thing here. I'm going to say this stuck equals stuck, and if it's undefined, that's the same thing as saying false. And then I need to say, by the way, this dot stuck is true, and this is this dot pos, tree dot pos. Okay, and I should really check against some other array, like the others. I'll call that, which is called tree. So what I want to do right now is I want to create one walker in the tree, and then I want to create in the walkers, I want to put just a random walker. So I have tree and I have walkers, and I might as well do that the same way in index spot 0. And then what I want to do is I want to see And you know what I should do is I should, now I can also have a function which is called this.show. And I can actually take all this code. I should have done this at the beginning. I can take all this code and put it in the object. So I can set a stroke weight, set a stroke, and this.pause, and draw the point at this.pause.y. And I could be a little smarter about this and actually just make this an ellipse. So I could be more precise about the radius, and I could say r times 2, r times 2, which is a global variable at some point, but I can have them be variable sizes at some point. Okay, so now I have this object. I have a Walker object which can move. It can check to see if it's sticking to anything else in some other array, and it can also draw itself. So what I want to do first is I just want to say, let me display everything in the tree, and let me display everything in the Walker's array. Okay, ready? So if I reload this sketch, Walker is not defined. Oh, sketch line 7, it's not defined because I have to remember to add a reference to it in my JavaScript file to walker.js. And missing walker.js line 25 has an error. So let me go down and see this.ellipse, this.pause.x, this.pause.y. I don't see any error here on line 25. Missing parentheses after argument list. Sketch.7, Walker is not defined. Function Walker. Period, no comma. Hold on, timeout. What am I missing here? Walker.js. Oh, is there a comma? Okay, thank you. Oops, I had a period there, not a comma. There we go. Great. So I should see here, whoops, I should see this is this and this is the Walker. So let's just now in Sketch, let's also have Walker's index I dot update. Oh, update was not it. Walk. So you can see there it is moving randomly. It's going to take a while to randomly intersect that. But it is walking randomly. I could obviously make it walk faster. So what I want to do now, actually, just as an experiment, is this is not at all, I've gone off the beaten path here from the actual probably algorithm. But I want to put 100 walkers into the space. Right? Okay, so they're all moving around randomly. And what I want for them to do is, if walkers, index I, check stuck others, then walkers, what I want to do is say walkers dot splice. I want to take it out of there, and I want to say tree dot push walkers index I. So I want to, what I want to do is I want to, anytime one of those walkers gets stuck, I want to put it in the tree, and I want to take it out of the walkers array because it's not something that's moving anymore. So let's check. This dot stuck equals true. So actually, let's make a function is stuck. Actually, so I don't need this variable. I can just say return true. And if it kind of gets to the end, return false. So let's look at that and see what happens. Others is not defined. Oh, tree, right? I have to pass in the tree. There we go. You can see them getting stuck. Go, go, walkers, go. Go, 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 walkers, go. So you can see how this takes a very long time. I'm kind of curious to try a few things. Let's try 1,000 walkers. And this isn't what Paul Bork describes what to do. on the website at all, but I kind of like, and so I kind of want to highlight them differently. So I should actually, by the way, I should have that be a particular variable, because what I would like to do when I draw them is if this dot stuck, I want to give them a different color. So let's so we can see which ones are stuck. So now, though, I think better than adding a ton. So let's still add it. Oh, let's actually do this particular algorithm multiple times per frame. Like, let's let it try to move all the walkers 100 times per frame. Whoa. Why are they all clustering near each other? I'm drawing them 100 times. I don't want to do this show. So I just want to show them once. There we go. This is what I was sort of hoping to see. So now, there, finally. Okay, so now we can kind of see the algorithm happening, which I think is kind of interesting. It's kind of happened very slow. This is a complete and total brute force method. But I finally got something that I like here. And because at least it's sort of interesting to watch, it is happening kind of slowly. I want to try a few things to make it happen faster. Let's increase to 200 walkers. And let's increase the number of times to 250. The frame rate is a little bit slower now. I kind of like to keep the frame rate up. So let's go down to 200. There we go. So we could obviously, and the other thing I could do, it's interesting. Oh, it's slowing down over time. So the reason why it's slowing down over time is there's more distance checking. So one thing that I could do that would hopefully help this run a bit faster, which normally I wouldn't care about, but it is kind of bothering me how slow that it's running, is let's see if we can eliminate the square root calculation and to see if that makes it run a lot faster. So one thing that I'm doing here in the check stuck function is using this distance function. And I want to write my own distance function. I'm going to call it distance square. Euclidean distance, and I want it between two vectors, a and b. So what I want is the difference in x, which is bx minus a dot x. I want the difference in y, which is by minus a dot y. And now, normally, if I would say return the square root of dx times dx plus dy times dy. This would be regular old-fashioned Euclidean distance, right? The square root of the hypotenuse of a triangle, a squared plus b squared equals c squared, or c equals the square root of a squared plus b squared. So what I actually want to do here is just write this algorithm, but take out the square root. And then what I can do now is not use this, but use my own distance squared function, and then I can actually have that distance be r times 4, which is what I want now is for the distance to be, did I mess something up here? Yeah, I'm missing a parentheses. What I want is the distance to be, instead of checking if the distance is less than r times r, I want the distance r squared, or r times 2 squared is r times 4. So this now, distance dist squared. This should hopefully be a lot faster. Wow, good. Okay, so boy, just eliminating that square root, you can see how much faster this is now. Okay, now here's the other thing: is every time I remove a walker, this is kind of nice actually, just to like let it grow with a fixed number of walkers. I'm kind of enjoying that, and I have sort of an interesting pattern. I don't know why. Oh yeah. Did the stream cut out? Oh, wait. Back. There was a technical glitch there, but hopefully you're still seeing me. I see myself again. So you can see here that I have this kind of nice finished pattern, which I really quite like, actually. So some other things that I can do here are, one is whenever I remove a walker, I could say like, I always want to have 200 walkers. So I can always say like, while walkers.length is less than 200, walkers.push new walker. So this is, even when they get stuck, I add new walkers. So I never, oh, and by the way, I started with, so let's make a variable called max walkers equals 200. And we're going to start with, we're going to do it, oh, no, that's a different value. Max walkers, I kind of made, and then I'm going to make another variable, which is iterations, which I'm also going to make 200. Let's make these variables, I think, is kind of nice. Right? And we can see how it behaves, So now I'm always keeping 200 walkers. So I want this really to happen pretty fast. So let's see if I can up the iterations a bit. And see if we can get this screen. Now, it is sort of slowing down. So I think we're in pretty good shape. Now, here's the thing. I think what's interesting, oh, you can see it really slowing down. So if I go back to, oh, and you know what? There's also a problem here, which is that I shouldn't be creating random walkers anywhere in the window. I should only be creating them around the edges. So let's also make that improvement, okay? I think it's worth making that improvement. So I'm going to go back into the walker, and instead of doing random width, random height, I need a function. Let's do a random point, and I'm going to give it that x and y. Right? I want to have some separate function somewhere that's going to take care of this for me. Actually, I'm going to say if x, this dot pos equals create vector at that x and y. So if you get an x and a y, otherwise, let's pick a random point. Now, I'm sure there are lots of clever ways I could write a function to give me a random point along the edge. But the way I'm going to do it is as follows. I want 4 possibilities: top, right, bottom, or left. So if I'm picking something along the top, I want a random x. And I want to return create vector that random x comma 0. Else if I equals 1, let's just say that's the bottom. And again, we could make this more efficient. Let's make that along the height. Else if I equals 2, I want a random y. And I'm going to along the left side. And in all other cases, I want a random point along the right-hand side. So let's run this now. You can see that I'm only picking random points that are coming from the edge, which I think is also going to work a lot better because I don't want to pick random points kind of inside the thing that I'm already creating. So here we have now diffusion-limited aggregation. Go, go, go. I wanted to finish. So one thing that I kind of miss, so this, I got to come up with a clever solution to figure out when it's done. Because you can see it's kind of, it's now like just infinitely picking points along the edge, and it kind of went crazy a little bit when it kind of got to the edge. So, but I kind of like the idea of actually, just for right now, not adding any more walkers and starting with a fixed number of points. So I'm going to start with 1,000 points. And yes, it is running kind of slow, but when those points are removed, we got to get our first point to get stuck randomly. There we go. I think it's going to kind of speed up over time, is my belief. But, and you know, one thing I could probably do, which might also help it run faster, is draw less stuff. Or what might be better is to just add 1 point at a time. So I think really the way that you would do this is let's just do 5 but like have like 1,000 iterations. Here's another way to doing it. Yeah, I like this. This is nice. Oh, I like looking at it this way too. So there's so many different ways we can visualize this. I'm kind of stuck on it. And I encourage you to sort of enjoy coming up with ideas on your own. But what I do want to do is, let's go back to this. What I do want to do is kind of look at how you can vary this algorithm to get different kinds of patterns. So let's go back and look at the Paul Bork website, and let's first sort of see a couple things. One is, right now this is essentially what I'm getting. You know, I could do a better job of kind of thinking about the layout of the space and making the algorithm more efficient, or you know, letting it run for a long time. I encourage you to do all that. I'm going to release a processing version of this, which maybe runs for a while and like renders the final version to an image. Somebody remind me in the comments if that doesn't exist, so we can make a version of it that looks like this. In the browser, it'll kind of, I don't want to like shut down a browser window, but let's at least first think, let's try to see how would we create this pattern. So this pattern, it's all about the seed points. What if I fill the tree with points along the bottom? So let's fill the, in the beginning, instead of having one point, what if I say for var I equals, I'm going to say var x equals 0, x is less than width, x plus equals r times 2. And what I want to do is say tree.push new walker at x comma height. So I just want to create a whole bunch of points that I start with at the bottom. And you can see what happens when I do that. Now, what if I think I want all my walkers actually just to start at the top. So let's go now to the walker file. And what if I basically say, you know what, let's just always have, I'm going to comment all this out, and let's always have all the walkers start at the top. So I just changed this function, have all the walkers start at the top. Whoa. What did I do wrong? The walkers are starting, timeout. What did I do? What did I do? Create vector x, return x comma 0. So it's at the top. And the tree is new walkers x comma height. Why are they getting stuck? Oh, no. Hey, let me just try something here. I think this I like better, but doesn't make a difference. That worked for a second. Random point. Let me put this back. Yeah, why are they? This works. Why if I only create them at the top, are they all getting stuck? Hold on. I need them, I'm debugging again in a sort of 110. I got to solve this. Okay. Do I equals P. Hold on. So you guys in the chat are probably giving me good suggestions here. There's one point at the top for whatever reason. Why is there one point at the top? You see what I mean? Hold on. What's this point? Why? Is that a walker or a tree? That's the tree. What's that extra point? There's a whole row of stuck ones at the bottom. There's supposed to be a row of stuck ones at the bottom. But what's this extra one at the top? What's this point? Where's the walker getting a point? Hold on. 0. I lost my mind here. It's in the tree. Add true in the constructor. Somebody is telling me something good, I think. The first one. Wow, there's an extra spot up there. I must have this in like a really obvious place that I can't see. X equals 0, x is less than width. Yeah, but I took out the whole dependency on that here. So y is one of them. Oh, I know what the problem is. Oh, JavaScript. You guys see what the problem is? Guess what? When x is equal to 0, it evaluates to false. Okay, let me back out of this for a little bit here. I want to get to where I was when I started debugging. So I can yes, Dr. Fresco is probably telling me this the whole time in the chat, and I just like didn't see it because there's too many other messages and I wasn't able to like get my head around it. Oh, what an awful mistake. Okay, so let me go back to. Okay, so look at the crazy walkers. I don't know what they're doing. Okay. I'm back. There was a major problem with my code, which is right here. Oh, this is, whoops. Okay, hold on. Try that again. I'm back. There was a major problem with my code, which is right here. Remember how I was saying I'm so clever, and I can check to see if the user gives it an x and a y. So if there's an x and a y, make a vector out of the x and the y, otherwise make a random point. Well, it turns out that if you give it the value 0, right, 0 evaluates to false. So when I say make a walker at 0, 0, for example, or 0, height, it's actually going to not make it at that point, but give me a random point. So what I actually need to do here is say, as long as x is not undefined, and I'm sure there's a more elegant way of doing this, but I'm just going to fix it right now and saying, and y is not undefined, do this. And that should, I think I have some sort of browser having crashed problem. Infinite loop problem. If x is probably oh right, I'm drawing them all again. Yeah, it's just slow. And then and also I think I can do away with this third argument stuck and just say this dot, you know, it's if I'm making it at a particular point, it's automatically stuck. Otherwise, it's automatically not stuck. Just to be clear about that. And now we should see, okay, so here we go. Now we have starting all the points at the top, and they're going to kind of get glued at the bottom. So this we should see some kind of pattern as this runs for a little bit. You know, speed ahead in this video if you want. You know, listen to some music while you're waiting. Come on, trees, grow. So so we should see a pattern that's coming much more like what we've got here in, oops, I'm in the wrong place, what we've got here in this particular example. So here's another, so come up with your own scenario. What if you start with points all along the edges? What if you start with points along a radial path in a circle? Or have points moving, you have points starting around the edges of the circle and your random walkers all start in the center. You can get something like this. Now, but I do want to add something else here, which is, whoops. I got too much music playing. Okay, I do want to add something else here. Let's just see how it's going. You can see, it's moving along here. We're growing our trees. I want to go back to Paul Bork's site, and you can see something here which is interesting. Look at this particular image. Now as I scroll down, look at this particular image, and look at this particular image. There's a kind of density or fuzziness or almost hairiness to it. And what you can actually do is, it's called stickiness. You can have a probability. You can think of when it touches something that's part of the this tree, this diffusion-limited aggregation thing that's growing, you could have a probability that it gets stuck rather than automatically getting stuck. So I think that's something interesting to add. For example, if it's within this threshold, don't just automatically have it get stuck, but pick a random number between 0 and 1. And if that random number, like our stickiness is now 10%, then I could actually have it get stuck. And unfortunately, we didn't get to see how that was going. Let me see if I can make this run a little faster. There's a couple things. So I'm gonna give it more iterations and more random walkers. The other thing that I could do actually that I think would really help is I could have the walkers as they walk, not just, I could have them only ever walk down. So I could actually say, I'm just going to comment this out. Var velocity equals create vector, some random amount between -1 and 1, and then some random amount between 0 and 1. So that these, the random walkers only ever move down. Boy, they move down much too fast. I guess maybe I should weight it just a little bit. Something like that. Oh, okay, hold on, too many. This was a nice idea that I had that doesn't seem to be working out very well. There, you can sort of see, I don't know if this was a good idea or not, but you can sort of see how if I have them randomly moving down, why do they always go back up to the top? I'm adding them back in again. That's making it run slower. So yeah, so I wanted to take that out actually. And you can sort of see, anyway, you can see that by varying lots of the algorithm. When I publish the code for this, I'm going to make you a nice clean version that works really well. Because there's so many variables you can play with here. OK, I want to play with one last variable. So look how slowly, like, come fall walkers, go to the bottom, stick to the aggregation pattern. Oh, OK, so let's do one last thing. What I'm going to do now, which I think will be particularly interesting, and, is try to recreate this pattern. Notice how the walkers at the center are larger than the ones on the outside. You can see this one as well. I didn't get to do didn't get to see the probability thing play out. Let me take that out for a second. And so what I want to do now, before I leave you, if you're still watching, is I don't want to have R as a global variable anymore. I want to have each walker have its own variable. So I'm going to make R 32. And I need to look for anywhere that I reference it, this dot R, other dot R. Right now I'm also importantly checking my own radius against another radius, or others index I dot R. And then I also want to draw it with this dot R, this dot R. So one thing that I could do, which is, and then I want to go back to the center, the version where it's where it's starting in the center, which I think is a bit easier to kind of work with right now. So I'm going to take out this tree that starts off the bottom. Let's just make sure this still works. Whoa, look at these. So if I make them really quite big, that was kind of interesting. Let's make this 8. Okay, so you can see what this looks like now, and this is working again now with just sort of larger circles. And I kind of would like to, just also when I draw them, I would like to give it a little bit of alpha here, I think would be worth seeing. Let's, just a little bit of alpha. Okay. So now we have the basic core algorithm happening, and you can see all of these walkers getting stuck. So what I want to do, I think, which I think would be interesting, is I'm gonna make the maximum number of walkers just 10, but I'm going to increase the iterations by 10 to 1,000. So these are the walkers now sticking one at a time. Now there are only 10 of them, so 10 of them are going to get stuck. That's all we're going to see. But now what I'm going to do is I'm going to, each time I delete one from the array, I am going to add a new one with a smaller radius. So what I want to do is let me get the radius of the last one in the array. This might be and I'm going to make a new walker with, oh boy, I want to make a new walker with that radius times 0.5, so half the size. The problem is now I need to make the walker be able to be created now with a radius, but at a random point. So I think one thing I need to do, one thing I could do actually, this is better, is I could say if arguments.length equals 2, that means I've gotten 2 arguments in x and a y, then create a walker with a radius of 8. Otherwise, then create it with the radius of, and then otherwise if, otherwise create the walker with the radius of the first argument. So if you have less than 2 arguments, so this is another way I could just check that arguments array. I have a video tutorial about that. Otherwise, I can make one with a particular radius. And so let's see what happens here. Okay, so where am I making walkers? So this is with, I forgot. No. So with, or else if arguments dot length equals 1, else, now with no arguments, right? Then the position is random, the radius is 8, and stuck is false. So now the other thing, whoa, what just happened here? So pause. Let's look at the sketch. Whoops, I have the third argument there. Okay, I had by accident, whoops. I had by accident a third argument left over for when I was passing true or false in for stuck. So if I take that out, whoops. Hold on. No, there's going to have to be an edit point here because I screwed this up. Yeah, a lot of people are asking about the grid optimization from the Poisson distribution, and absolutely we could add that in. But hold on a second. I want to fix this. I realize I have some. Okay, so back. I realize there's a problem here where I'm passing in 3 arguments because I had an extra stray true from before. So let me take that out. And you can see this is working now. Strangely enough, though, the walkers are getting like really, really, really small, really fast. And I just realized that's because what I want to do is get that, before I start adding a whole bunch of them, I want to get the radius of the last one there. Because when I add one and get the radius of the last one, they're getting smaller and smaller. And let's just make them go down by 75%. So you can see here that the walkers are getting smaller as they add them back in. And maybe that's like too much. They just get smaller so quickly. So let's see what this does. Yeah. So you can see over time, as I'm adding more and more walkers in, they're getting smaller and smaller and smaller. We could also do something now while we're here. Let that run for a little bit. Let's see if I give it 50 at a time. Will it kind of perform okay? So one thing that I want to do is, and I actually could just have every walker in sequence be actually a little bit smaller than the previous one. That might actually be a better way to do it, because I could have like a radius counter, and that's kind of, yeah, let's do it that way actually. Let's try this. I want to have a radius, a starting radius. I can actually just say radius equals I can have a starting radius just for that center one. No, that's fine. Radius. So I want to have a starting radius of 8. And whenever I make a walker, I say radius times equals 0.99. So shrink it a little bit. Shrink it a little bit. And then there's another place where I make new ones, which is here. Shrink it a little bit. And then actually, I can take out this idea of the argument, because I'm just going to use a global variable. I don't love this anymore. I'm just use a global variable, radius, that's always shrinking, to go back and put that in here. And have this always be radius, radius. So there is only back. Now I'm sort of simplified back to just 2 cases. I either am getting an x and a y, and this dot r is always just equal to that global variable. I don't like now how I've done this, but we're going to do it this way anyway. So you can see every single one is like 1% smaller than the previous one, which is kind of interesting because we're getting sort of, they're actually not exactly in order. So that's not what I intended to happen, but we are seeing sort of an interesting result from this, and they're getting smaller and smaller and smaller. And then I could also say, what I like about this is I now have sort of like a terminal point where I can say if the radius is less than 1, only bother to do this if radius is greater than 2. So now we actually, like, I don't want to have circles where the radius is less than 1. So now we actually have a terminal condition for this algorithm. And I also now want to add one last thing, which is coloring them. So, I could actually, so the other thing we could do is I could have a, I could map their hue. So I could say, color mode, HSB, and in the walker object itself, got to add this in. I could say fill. I could say the hue is mapped to the radius, which goes kind of between like 0 and 8 to between 0 and 360, and I could give it that color. And I think I'm actually going to say no stroke. And let's forget about the coloring it based on whether it's stuck or not. And I have an error somewhere. So we can see now, and they're not actually, so I probably should order their color based on when they get stuck. But this is kind of interesting nonetheless. And you can see as they're getting smaller and bigger. And you know, I don't know why it just stopped right there. Oops. But you can see I'm going to clean up this code and give you a working version. I might change the order around the colors. I'm going to, I'm very good at crashing Chrome, but you can see sort of the ideas behind this particular algorithm. I don't really, my time is up, I think, because this has gone on for way too long. I don't have a good, perfect version of this to show you, but I will include that in the link from this video to the source code. I'm going to make both a P5.js and a processing version of this, so I can do kind of like a higher resolution one that kind of generates it and just saves it to like a JPEG, so you can see how that works. Maybe I'll come back and do another video follow-up about that. But now you can see sort of the basic idea and the implementation behind this particular algorithm that's on Paul Bork's website. Okay, thank you for watching.
Write the colors of code, you can follow the road to
And I'll see you in another coding challenge soon. Okay, I forgot, I should have break from the loop. Where did I break? Where did I miss? So I'm gonna fix this now. I've got to go actually. This was So first of all, I absolutely could use the like tree thing. I should break from the loop. So where should I break? If it's stuck, remove it. Oh, you know what? This should I should really go through the loop backwards. That's bad, because I'm removing from it. Oh, this is the problem, of course. While and radius is greater than 1. So I should do that test there, of course. I'm going to come do an addendum. So, and then also I want to just create, so each time it gets stuck, then I'm going to say, I'm going to change I'm going to set the hue actually the moment it gets stuck, so it actually has no color until it gets stuck. And so I'm going to go back to saying it's white, or it's and I'm going to say this dot hue equals hue. So I'm going to give it a hue the moment it gets stuck. And so now, whoops, this dot stuck otherwise. Why? Oh, because I'm in HSB mode. How do I get it to be white in HSB? Oh, no saturation. There we go. Right? No. Hue, saturation, brightness, right? Oh. How do I get white in HSB? And I'm losing my mind. And let's have the, let's make shrink a variable. So, oh my God, it's 1:37. I really have to go. Am I still mapping it from? Ah, whoops. There we go. wait, this dot hue. That's happening. Why is this not? Oh, whoops. I'd had the saturation off. There we go. Okay. Yeah, the hue is going to have to increase a little bit more, and the shrink is much too. There we go. This is what I was attempting to do. I'm going to come back for a second. Back for a quick addendum. I kind of cleaned up the code a little bit and it's making it work a little better now. I had two big things that I missed. One is that it was crashing the browser. I think I need to point this out because I had this while loop that was always trying to fill it. I was trying to fill it if it ever got less than a certain amount, but I didn't allow myself to add any if radius was below a certain amount. So it got stuck in that while loop. So I fixed it to just say only do the while loop if radius is greater than 1. And the other thing that I did is I added a hue variable so that each time it gets stuck, I increase this sort of global hue variable. And you can see now the hue is sort of assigned to the order in which it gets stuck. So this doesn't exactly match what you see on these particular scenarios, but I bet you with a little bit fiddling and tweaking of the algorithm, you could get something like that. So give that a try, and and as you make more beautiful and interesting versions of this, think about ways of optimizing it, of where you start the walkers, how many you use, how you check to see if they're near something. We'll come back and I'll make some improvements to this. Okay, this is really the end now. Goodbye. Okay. So I'm sorry, everyone, that I'm now going to be rushing to leave. Normally I would take some time to answer questions, but I forgot that I made some appointments here starting at 1:30. And I'm just going to say, I'm just going to send a message saying that I'm running a little bit late. I'm going to check here. To see, sorry, I'm trying to look. I'm trying to look for my message. Ah, here we go. To see how late I am. Oh, whoops. I'm not finding it. Now I'm wasting all this time trying to. Here we go. Almost there, everyone. And I'm going to go to home. Ah, OK. So that's fine. I'm only like about 10 minutes late, which I think is not that big of a deal. So let me just check back to the chat again to give you guys a few parting words. Okay, I hope you guys I hope everyone enjoyed this today. It was a little bit crazy. I hope 2 video tutorials will come out of this, both much longer than I could have ever anticipated, and hopefully somewhat useful. I will also be releasing the code. I have of a mind to like redo these challenges again, having done them once, but I guess, you know, to leave them messy and crazy, that's kind of the way that it is. So I'm going to get going. Just to quickly remind you guys, if you, I'll be doing one live stream again next week. This is the last live stream for this week. If you want to sign up for an email list, look, this is me live right now. If I hit play here, look, there I am on my website live. You can put your email here at codingrainbow.com. I'll send an email over the weekend or Monday, kind of letting you know when the time will be for next week if you want to tune in live. If you subscribe on YouTube, you'll also get a notice. And I have a Slack channel where you can suggest topics and ask questions. And there's a small discussion group there if you want to sign up for the Patreon, which is a crowdfunding website. I also have stickers available via Sticker Mule. You can tweet me if you're interested in those. They look like this. You can buy them. If you're in New York City and I run into you on the street, I will hand one of these to you. And I had t-shirts available at one point, but those are no longer for sale, but I'm going to do another run of them. So if you're interested in that, let me know, or better yet, you can go to cottonbureau.com/product/codingrainbow, and you can put your email in here. So far, 11 people have requested that the t-shirts. I think they run them again once it gets up to 40. So I think that's about all I have to say. I don't know what I'm going to tackle again next week. So send me your suggestions on GitHub, on Twitter, or if you're in the Slack channel, that's where I'll be sort of posting what I'm thinking about and the kind of different things that I'm looking at. So send me your feedback. Yesterday's live stream, it wasn't yesterday actually. Yesterday's live stream I just released. It's here, Coding Rainbow Live number 55, and I did a Flappy Bird and an Agarrio clone challenge. The Agarrio one, I only just did the basic mechanics. I didn't actually get to all the networking multiplayer stuff or a lot of the features. I will try to come back to that at some point. So many topics, so little time. So thanks again. I'm looking in, do I do any CSS programming? A little bit, and I do have, if you are interested, if you go under these playlists, number 7 is a whole set of tutorials about HTML, CSS, and the P5 DOM library, which I encourage you to check out. If you're interested in learning more about Git and GitHub, there are these videos, the Connect, some WebSockets. I've got a lot of stuff in here. So, please be in touch. Thank you, as always, for watching. Thanks for your enthusiasm. And I'm going to dance my way out of here, I guess.
Ride the colors of code, you can follow the road to Coding Rainbow.
Awkward. Oh, it's awkward that I'm still here, right? So I have to press a button to stop the stream. Should I try that again to be more elegantly about it? Ooh, did I not? Oh, I didn't press it correctly.
Ride the colors of code, you can follow the road to Coding Rainbow.
Bye.